In this video, we'll show how to determine whether an alternating series converges absolutely or conditionally or diverges. That is, we'll discuss how to use the alternating series test. First, we have to identify that we have an alternating series. That is, let's pull the alternating component from the expression in the series. Here we're going to take the -1 to the power n minus 1 out by using the properties of exponents, and reciprocal of 1 or -1 to any power is just the expression itself. So I can rewrite this expression like this: -1 to the power n minus 1 times 1/3 to the power n minus 1. So now it is clear that we have an alternating series, and if we would like to use the alternating series test, we have to verify the following three conditions. First one is that the non-alternating part is always positive. So here it is pretty straightforward. 1/3 to the power n minus 1 is always positive because the base is always positive. Second condition is that the limit of the nth term must be equal to 0. So in our case, we have the base less than 1 raised to the power infinity, which is of course equal to 0. And the third condition is that the sequence made of the terms of the series must be decreasing. And to do that, we will have to prove this, that the successor is less than predecessor, and this is pretty obvious because 3 to the n is less than 3 to the power n plus 1. So all three conditions are verified. That means by the alternating series test, this series converges. So we just have to write converges by the alternating series test. Now, once we determine that the alternating series converges, the next question is, does it converge absolutely or conditionally? And to answer the question like that, we have to consider the series made of the absolute values of the terms of the original series. That is, the question now, does this series converge or diverge? So we just ignore the alternating component, and this series clearly converges because it is a geometric series with the common ratio 1/3, which is less than 1. Because this series converges, the original series converges absolutely.